Digging a tunnel under the heart of Kuala Lumpur is a monstrous task. Beneath some of the city's busiest roads, adjacent to heritage buildings, and through some of the toughest ground conditions in the world. The highly complicated underground section of the new Klang Valley Mass Rapid Transit, or KVMRT, is being executed by Malaysia's best underground tunnelling team. This is their story. The Klang Valley Mass Rapid Transit, or KVMRT, is a rail-based public transport that will become the backbone of the new sustainable transport system for the Greater Kuala Lumpur. The first line, which stretches from Sungai Buloh to Kajang, is 51 kilometers long with 31 stations. With no pre-planned corridors in the city for a network system, 9.5 kilometers of this line is being built underground. The design and construction of the underground works was awarded to MMC Gamuda KVMRT Tunnelling Sdn Bhd for their extensive tunnelling technology and experience. 10 tunnel boring machines, or TBMs, are commissioned for this project. TBMs excavate rocks and soil with special tools fixed on a rotating cutter head while building permanent walls at the same time.
Tunnel boring machines are essentially cutting tools for the ground. You can refer to them as a mole. In most cities now, for railway, the tunnels are built using TBMs because of safety issues and because of ground conditions.
The ground conditions in Kuala Lumpur consist of the Kenny Hill Formation and the Kuala Lumpur Limestone Formation.
Because of MMC Gamuda's experience on previous tunnelling on the Smart Tunnel in the same area in Kuala Lumpur, they know the ground conditions pretty well. And therefore, we have come up with a machine that is specifically suited for each ground condition.
Of the 10 machines, 4 earth pressure balanced TBMs will tunnel through the Kenny Hill Formation, while 6 variable density TBMs will be used to tunnel in the difficult karstic Kuala Lumpur Limestone Formation.
Karstic limestone, by its nature, has certain cavities which have to be managed when you're tunneling through. So we have now come up with a design that we believe can mitigate some of these issues as we find them.
The variable density TBM is the first of its kind in the world and is a result of combined initiatives from Malaysia's tunnelling experts from MMC Gamuda and Herrenknecht of Germany.
It's a product of ideas, opinions and experience from all quarters. It's a very comprehensive machine. You can say it's very special because no machine has been designed like this before.
The machine is designed to be safer in Kuala Lumpur's treacherous underground conditions.
I think far more important is the safety that it brings to not just the people but the property on the route. When we deal with karstic limestones and we find solution chambers and cavities that could actually cause mini collapses, or the ground subsidence could bring some neighbouring structures down. This way at least we are saving millions in terms of protecting this property, and that I think is far more important in terms of safety.
After more than 2 years in the design stage and 9 months of construction, the first variable density TBM is ready to be tested.
We have only seen it on the drawing board so far, so this is the first time that it is all put together. This is very important to us because this is the last chance for us to make final modifications and to be confident that this machine is workable and everything is functional before we send it to the site.
But before the TBM can mine, its launching site needs to be prepared first. At Cochrane, a 30-meter deep shaft was constructed for 4 variable density TBMs to launch.
The timely readiness of the shaft for TBM to launch is very critical. We have chosen control rod blasting, which we will use to break down and loosen the rock, and from there we will excavate 30 meters below ground.
The first TBM arrived in Malaysia in early February 2013. Transporting it to the site through Kuala Lumpur was a massive challenge. Much planning was needed for the assembly of the machine, as any damage would require custom repairs in Germany.
This is a very complicated machine. If you compare it to a normal slurry machine, I think it will have 30 to 50% more components. And we are also dealing with very delicate components, very heavy, looks very tough but very delicate. We cannot afford to damage it. If the extent of damage is huge, then the impact to the project will be tremendous.
The assembly of the first machine took approximately 2 months to complete, and by June 2013, the first variable density TBM began mining.
This machine took a little bit longer than we expected, but since it is a brand new type of machine with a lot of extras, so I am quite happy that we could finish it in this time, and now it is excavating. You can hear the stones moving around in the pipe, so it's a fantastic noise, it's my favorite.
The TBM both drills and builds tunnel rings, which become the walls of the tunnel. It takes 7 segments to build each ring. Just like an arch, it is the keystone that holds everything together. One segment is 2.2 metric tons and is lifted by vacuum only. The giant hydraulic arms of the erector can position the segments down to the millimeter. These huge concrete lifters are controlled by the ring builder using a tiny joystick. It takes an average of 45 minutes to build a ring, with a best-to-date time of 30 minutes. A total of 11,500 rings are needed to line the full 9.5-kilometer tunnel. The tunnel walls need to be strong enough to withstand extreme pressure and chemical attacks from the ground and water, and to also endure settlement caused by poor ground conditions. The lining of the tunnel is manufactured off-site at 2 different factories. Polypropylene fibre is added to the concrete to improve fire resistancy of the tunnel wall and to withstand effects caused by the train crossings. More than 80,000 segments plus 11,500 key segments need to be produced. At maximum speed, the plants can churn out more than 2,000 segments a week, enough to feed all the tunneling teams. The TBMs are fed with a constant stream of concrete segments. The deeper the TBM goes, the hotter it gets. Giant fans pump cool air into the ventilation ducts that stretch all the way to the TBM. The tunnel is like a giant artery, feeding the men and the machines with vital supplies, power, water, grout, and a crucial material, bentonite slurry. The thick grey liquid plays an important role. It keeps pressure on the rock face and acts as a protective coating to the giant drill as it grinds forward.
Variable density machine, as the name suggests, the machine is capable of varying the slurry density at the excavation chamber of this machine. It actually prevents the blowout to the surface when we use the sufficient pressure to counteract the existing ground and water pressure. In the normal slurry density, the same pressure is going to push this slurry all the way up to the surface, especially in shallow condition. And secondly, with a high viscosity, we slow down the losses of bentonite in the very cast condition in the limestone. In the normal slurry machine, the slurry will lose out so fast that we will be delayed in the machine's response in injecting sufficient slurry back to counteract the losses.
The slurry also carries the mined waste out of the tunnel. Above ground, a massive slurry plant is working around the clock to process and clean the slurry coming from the TBM through a series of screens.
What the separation plant has to do is to ensure that the screens are all working perfectly, there is no clogging in the screens, and to make sure that all the conditions of the motors and also the screens are in 100% good condition.
The clean recycled slurry is then piped back underground via giant pumps to the TBM to start its journey all over again. While the variable density TBMs are used to mine the karstic Kuala Lumpur limestone formation, the earth pressure balanced TBMs are used to mine under the more stable Kenny Hill ground conditions. Unlike the variable density TBMs that need slurry to keep the pressure up at the cutter head, the earth pressure balanced TBMs use excavated soil to support the tunnel face by balancing the earth pressure against the forward pressure of the machine. The first 2 earth pressure balanced TBMs are being launched at the Semantan portal. This is where the elevated section of the KV MRT goes underground.
Over here, from Semantan to Pasar Seni, we are using the EPB machine, earth pressure balancing machine, to handle the Kenny Hill formation. So the excavation is not so complicated.
In the TBM, excavated material is transferred from the excavation chamber onto a conveyor belt. The material is then dropped into muck cars and transported out of the tunnel. The excavated material is then stored temporarily in muck pits before they are removed from the site. After mining for a certain distance, the TBMs need to stop for an intervention.
We're having this intervention stop to have a check on the cutter disc. Cutter discs are like the knives of the machine that cut through the ground. So we're just going to check whether we need to change them or not so that we can further mine.
Tunnel engineers first need to determine whether the ground conditions in front of the cutter head is safe based on soil investigations done beforehand.
The first thing I'll be concerned with is the pressure in the front. Before the men go inside and do this maintenance, we have to make sure that the pressure is okay in the front.
The cutter head lies in the forward pressure zone. Before any work can be done, the area needs to be cleaned first. The TBM's cutter head is armed with 37 tungsten carbide discs to mine through the rock and soil. After mining a certain distance, the cutter discs have worn down and need to be replaced.
We already finished the inspection for the cutter head. So we found only one disc and one knife bucket have to change. So now we do the preparation for the changing.
Inside the cutter head chamber are some of the worst conditions a tunneler can face. There is barely any space to move and temperatures can rise to about 45 degrees Celsius.
It's certainly not the best space to work at. It's very hot, very stuffy, and you can't really hear because it's too noisy in the front.
Each cutter disc weighs about 200 kilograms. An hour later, the new cutter disc is in place and the TBM is ready to mine again. There are another 2 launching sites for the TBMs. The Inai shaft is circular with a depth of 34 meters, where one variable density TBM will be launched towards Bukit Bintang.
The main challenges, of course, in this site is the space constraint. In a normal launching sequence, you have a big box opening. But for here, we actually limit that space to a small opening. That means that inside the ground, we have to do a horizontal tunnel using blasting method so that we have space horizontally to lower down the machines.
Another challenging site is the Pudu shaft, which will be an escape shaft for this line in the future. Here, one earth pressure balance TBM will be launched. Due to space constraints, the shaft is built in a top-down construction method. At the roof slab, 2 openings will act as access points where the huge TBM parts will be lowered and assembled. Before a TBM ends its drive, work needs to be done to ensure that the machine breaks out smoothly at the right position.
So we just only install that seal ring and then also cut like a cake to reduce the overbreak so that later when the machine comes in, it breaks into small pieces.
On the 24th of December 2013, the first earth pressure balance TBM from Semantan broke through at the KL Central Station.
Yes, great. Finally, I pushed my machine, came in. I've been working for more than 24 hours. I can have a good rest.
2 weeks later, the first variable density TBM breaks through at the Pasar Rakyat station.
We've gone through risky areas, we've gone through under sensitive structures, and we've had occasions where we had slurry blowing out, and as soon as we swapped to high-density slurry, it has stopped. So the added facility of the variable density is proving successful.
It is clear that the machine has started. We hear some noise and the slurry is coming out, so I'm sure very soon you will see more cracks appearing on the face, and then soon you will see the face starting to drop.
Great moment for us, and we have proven that we have done well, and I would say that we will continue for another few more machines to make sure that it's come out as well as it is.
Tunneling beneath Kuala Lumpur for the city's new mass rapid transit is a mammoth undertaking. As of March 2014, 50% of the work is completed, and the MMC Gamuda KV MRT tunneling teams are ready to take on the challenge to reach the finish line.